Okay, so here we are. Question number one. They're wanting, they're giving us this graph, and they want us to work backwards from the graph back to the formula. Here, let me move it down where we have some space to work on it. So yeah, how do we go backwards from a graph to the formula for the function, the equation for the function? Well, of course, thank you. Yeah, so that's the whole trick. I put that in the notes for you. Let me go to the notes here. There it is. So I'm looking right here. This is the exam 2 notes. These are now complete. There's a lot of stuff on them. Coming on down to the thing we're at right now. Here it is. Right. No. There we go. Roots, also called zeros. Yeah. So that's where we're at. So I put this in the notes for you, and this is example 2. Yes, we have 2 examples of this, an easier and a harder. Let me bring it over where we can work on it. And so there we go. We'll start with this easier one here. Okay. So here we are. This is from the exam 2 notes. Exam number 2 notes. Okay. So what is it showing us? It's showing us these 3 roots. And it's saying, okay, the roots, what are roots? Roots are places where the graph hits 0. They're called roots or zeros. Yeah, right up here, also called zeros, because it's where the graph is at a height of 0. So roots or zeros, places where the height is 0, roots. And so what does that mean? Well, basically what you do is the general form is going to be k x minus r1 to the power called the multiplicity, x minus r2 to the power of the multiplicity, x minus r3. So you basically go x minus root 1, x minus root 2, x minus root 3. And you plug in the roots and the powers. So notice I took the -2 and I put it in right here. X minus a -2 is going to become x plus 2. And then I plugged in the other root, x minus a -1 is going to become x plus 1. And then x minus 3, that's just x minus 3. And then the powers, how do the powers work? Well, I'm saying it right here. The power is 1 when it passes through. So if you go, that's not what I meant to do. Here we go. Notice at this root right here, the graph passes through. It's high and it passes right through. And then at this 0, it also passes through. And then at this 0 right here, it bounces. I'll put a B for bounces. See how the graph bounces there? It comes in, goes boing, bounces. It did, instead of passing through the x-axis like it does at these 2 places it passes through, at this place it bounces. Well, the power is 2 wherever it bounces. How do we know that? Well, you know the graph. Remember the graph of x squared? What does that look like? It bounces, huh? Right, x squared is a bouncer. So no big surprise. Whenever you have a bounce, that's going to be power of 2. That's why the one at 3, x minus 3, ends up having a power of 2. Whereas the other guys just have a power of 1 because they're a passer througher. And then final step, solve for k by plugging in the y-intercept. All right, let's do it. And so on this question, let's grab the 0. So it's going to be y equals k. It's going to be x minus, x minus, x minus. And then grab the roots. So -2, 2, and 4. So -2, 2, and 4. And then what powers? Well, this one's a bounce. So that one's going to be a second power at -2. Whereas at +2 and +4, it just passes through first power, right? So the bounce, oops, I'm not spelling bounce right. Bounce is the second power, and the passing through is a first power. So there's the general form. So that's how you write a formula from an equation. We're not done yet. That's the first step, though. So you've got to look at all the places where the graph hits 0. Those are called zeros or roots. And you write a parenthesis for each one. X minus the root in each case, and then the power, 2 if it bounces there, like x squared, 1 if it just passes through, like it does there and there. Okay, so then what do I have? We have y equals k, x plus 2, right? Double negative becomes positive. X minus 2 to the first, x minus 4 to the first. Now, what do we do at this point? Now we plug in, go back to step 3. Now we're ready for step 3. Solve for k by plugging in the y-intercept. So let's do that. So this is step 1, step 2, step 3. Plug in the y-intercept and solve for k. So what's the y-intercept? Right there. Because this is the y-axis. So where a graph hits the y-axis, that's a y-intercept. What's the coordinates of that point? Over 0, up 2. Y-intercept is 0, 2, which means x is 0, y is 2. So let's plug that in. You plug in 2 for y and 0 for x. And so we get 2 for y, 0 for x. 2 for y, 0 for x. So there's x, 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 and 2 for y. And so what do we got? 2 equals k, 2 squared times minus 2 times minus 4. What's that? Positive 4 times positive 8, right? Negative 2 times negative 4 is positive 8. 2 squared is 4. And so what is that? 4 times 8, 32. Last step to finish solving for k. Divide by 32. So k, or I'll do it over here. K equals 1/16. Right? Is that too fast? So now I can make it 2 over 32. And then divide top and bottom by 2. It's 1/16. So we got k. We've got our deal. So it's going to be k, which is 1/16, times x plus 2 squared, x minus 2 to the first, x minus 4. And you don't have to show those first powers. They're automatic. So there's our k right in the front, and then there's everything else. So there's the formula for that graph. That's kind of amazing. We can look at a graph, and from a graph, we can work backwards to actually find the formula for that graph, the formula that will produce that graph. That's pretty advanced and sophisticated math work there. So we can look at this big fancy U-shape, W shape, I guess, graph thing, and work backwards to the formula to produce that graph. There it is. Just like that. So again, what do? X minus each of the roots or zeros. They're called places where the graph hits 0. Here, here, and here. And then the power is 2 if it bounces there. It's 1 if it passes through there. And then you clean that up, and then you plug in the y-intercept to solve for k. So the y-intercept right here, 0, 2. X is 0, y is 2. Plug in the 2 for the y, the 0 for the x's. Get that equation, solve for k. K is 1/16. That's your number in the front. There we go. Questions on that one?